There's two types of problems you're going to see. One type I like to call the monomial type. Notice there's no addition or subtraction in part A. It's just a monomial over a monomial times a monomial over a monomial. There's no addition or subtraction, nothing crazy. This type you're not going to factor. Instead, you're going to combine all of the top, combine all of the bottom, and then we'll work on simplifying. So on the top, we've got 4 times -6. That would be -24. Combine all of our x's. X to the third means that there's 3 factors of x in this first fraction. X to the second means there's 2 factors of x there. 3 and 2 would make x to the fifth. There are 5 factors of x total. 3 of them over here, 2 of them in the second fraction. How many factors of y do we have in the numerator of these two fractions? 3. We've got 1 plus 2 more, so we've got y to the third. On the bottom, same thing. 3 times 10 is 30. We've got an x and x to the fourth, so that would be x to the fifth, and we have y to the fourth. Now we need to look at simplifying. So first we can simplify the numbers. -24 over 30. If you do not know how to simplify fractions in your calculator, please see me during work time or before school or after school or sometime when we have a few moments, because you really need to have that skill so that if there's a fraction that you don't know how to simplify, you know how to plug it in your calculator and get a simplified fraction. This would simplify to -4/5. Now for the x's. We've got x to the fifth on the top, x to the fifth on the bottom. What's going to happen with the x's? They cancel. Now for the y's. Y to the third means that there's 3 y's on the top. Y to the fourth means that there are 4 y's on the bottom. The 3 y's on the top are going to cancel out 3 of the y's on the bottom, leaving us with how many y's on the bottom?
1.
Just 1. So you can draw that out, or you can think about these 3, take out 3 of the 4, leaving us with 1 left over. Whatever you need to do in your brain to make that make sense. Our final answer is -4 over 5y. Part B. If you see something that isn't a fraction, you can always put that over 1, and then suddenly you have a fraction. This is the factoring type. We've got binomials, we've got things that we could factor. So on the numerator, in the numerator, we've got an 8 from the first fraction. What do 9 and 12x have in common? 3. So we can factor 3 out. 9 divided by 3 is 3. 12x divided by 3 is 4x. On the bottom, we have 3 plus 4x from this first denominator. We also have a times 1. Do we really need the times 1? No. Now, do you see anything on the top that matches the stuff on the bottom that we could cancel out? So our final answer is 8 times 3 divided by 1. What is 8 times 3? 24. There we go. And 24 divided by 1 would still be 24. All right. You are going to have one problem similar to part A, so I do want to show you this problem. Okay, we've got 2x minus 3. 2x and 3 don't have anything in common, so that can't be factored. X plus 4, that's pretty simple. That can't be factored. And we've got a 9 and an x squared. You don't need to split up the 9 and the x squared, but I do want you to realize that 9x squared is not one thing. It's a 9 times an x squared. On the bottom, we've got x to the fourth. Now, this thing, 3 minus 2x. Do you see anything in the numerator that is kind of similar to 3 minus 2x? 2x minus 3. But the problem is, this is positive 2x and negative 3. This is positive 3 and negative 2x. The negatives are in the wrong place. We can actually factor this. We can pull negative 1 out of this. Positive 3 divided by negative 1 is negative 3. Negative 2x divided by negative 1 is positive 2x. Then we could rewrite this in 2x minus 3. So we are going to factor that weird denominator so that it matches one of our numerators. If you see a denominator and a numerator that are really, really similar except the negatives are messed up, factor out a negative. Now let's look at what cancels. What cancels? The 2x minus 3 cancels. Anything else? This x squared means x times x. This x to the fourth means that we have 4 of them. These 2 are going to cancel out 2 of the 4, leaving us with how many x's left on the bottom? 2. Or you can think of it this way. This x squared is going to cancel out 2 of the 4, leaving you with 2 left. So our final answer here, we've got 9 on top, and we've got x plus 4. On the bottom, we've got x squared. We also have a negative 1. It doesn't matter where the negative is. If you have a negative somewhere in this problem, I would stick a negative in front of whatever you have on top. Where the negative is doesn't really matter, so it's most mathematically correct to put that negative up on the top. Okay, B is my favorite type of problem because it involves some fun factoring work, and we love factoring, so this is fun. We need to factor, 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 and then cancel things out. So I'm going to draw, I'm kind of running out of space here. No, don't go to the next slide. There we go. We are going to start by factoring the first numerator, x squared plus 5x plus 4. We are looking for 2 numbers that multiply to give us 4 and add up to 5. What numbers do you think would do that? You're right. It's 1 and 4. So that first numerator factors into x plus 1, x plus 4. Now let's look at x squared minus 9. Do you know how x squared minus 9 factors? This class is really chatty today. Really chatty. X squared minus 9 factors into x plus 3 times x minus 3. That's the difference of 2 squares. My first denominator is pretty simple, but we can put it in parentheses. And now we need to factor the last denominator. We are looking for 2 numbers that multiply to give us 1 and add up to 2. How can you multiply to get 1? 1 times 1, and 1 plus 1 is 2. So this factors into x plus 1 times x plus 1. So factor, 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 factor. Get all of it factored, all of the numerators on top, all of the denominators on the bottom. Now we get to look at what cancels. So what do you see on the top that matches stuff on the bottom? X plus 1 cancels out one of the x plus 1s. X plus 3 cancels out one of the x plus 3. So our final answer here is x plus 4 times x minus 3 over x plus 1. Okay, we skipped an example. If you would like help going through that example, please let me know. You can come in wildcat hour, before school, after school, whenever works for you, or talk to me during class. Let's talk quickly about dividing. We don't actually divide fractions. Instead, we multiply by the reciprocal. And I think you've heard the KCF phrase before, keep, change, flip. Have you heard keep, change, flip before? Yeah. Keep the first fraction the same. So in this example, we would keep 2x over 5. That first fraction stays the same. We change this sign. Instead of division, we are going to multiply. We're going to multiply by the reciprocal. So you take the second fraction and you flip it. Keep the first fraction the same. Change the division sign to multiplication, flip the second fraction. What you're actually doing here, instead of dividing, we are multiplying by the reciprocal. Then you would finish this just like we've been doing with multiplication. So let's go to the next example. The very, very first step that I want to do, because I see that this is division, we're going to keep the first fraction the same, change the sign to multiply, and flip the second fraction. Now I want you to pause the video and take a moment to factor whatever numerators you can, factor whatever denominators you can, and I'm marking which numerators and which denominators need to be factored, and then look at what cancels. So take a moment, I'm serious, pause the video, factor the circled things, and then we'll look at what cancels. Okay, now if you need to pause the video and look at each of these, go for it. The green was a trinomial, so you factor it by finding two numbers that multiply to give you 8 and add up to -6. The blue and the purple were both greatest common factor. What do those two terms have in common? Pull that outside of the parentheses. Once you have everything factored, what cancels on the top and the bottom? X minus 4 cancels. X minus 2 cancels. Anything else cancel? The x. So what's left? 2/3. Definitely simpler than what we started with. We aren't going to actually do this example. I just want you to make sure before you start any problem, look carefully at what symbol is between. If it's multiplication, go ahead. Factor, 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 cancel. If you see division, make sure first you keep the first fraction the same, change the sign to multiply, and flip the second fraction. Then factor, 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 cancel. See if there's anything else you need to see. I don't think so. We're going to edit this assignment slightly. We're going to skip number 22. And then I believe we are skipping 36 and skipping 46. So that's 7 problems total.